Hey everyone, and welcome back to the Data Idol Summer School. I'm Amy, and I'm the Senior Events Coordinator for the Data Science Festival. The purpose of the Data Idol Summer School is for people that are transitioning into data or just kickstarting their career. We have around 40 sessions running from August to October, which you can watch along with the community. We also have a Slack channel that you can join, and we'll be popping the link into the chat during the session. If you'd prefer to watch the sessions in your own time, this will also be an option which will be available from September onwards. I'd now love to say a huge thank you to all of our summer school partners and all of our summer school speakers. They've given up their time to support the data science community. I'd now like to introduce Simeon and Erin, who will be presenting their talk, Introduction to Git. I'd love to say a huge thank you to everyone who has supported us, and we hope you enjoy this session.
Hello, my name's Aaron. I'm from Infinity Works. I'm an associate consultant, and this is my friend Simon.
Hey there, yeah, I'm Simon, and I'm also an associate consultant at Infinity Works, which is part of Accenture. And today we're going to be taking you through an introduction to Git. So I'm going to let Aaron just give us a brief overview of the main topics we're going to be talking about today.
So we're going to start off with source control, and we're going to describe what source control is, why we use it, and what the benefits of using it are. Then we're going to talk about Git and showing you how to use it with repos and all that sort of stuff. And then we're going to move on to sharing code. So if you're working on a collaborative project with other people, or you're just trying to bake it up, sharing your code to another location into the cloud, that's what we'll be delving into there. And then branching, this is about if a code stream is being worked on actively, you'll want to split it out and multiple people work on different things at the same time. Merging, this is pulling it back together. So once you've finished working on it, bring it back into the main stream. And then pull requests, which is pulling it down from the remote server onto your local client. So the main learning objectives for this is going to be basically understand what I just went over in the overview. So by the end of this, hopefully you'll be able to describe what source control is and why we use it. You'll understand how to create a Git repo, how to create branches, how to add commits, how to make a push to the remote, how to create, review, and merge pull requests. And what would a world be without version control, Simon?
Well, it'll be a very messy one, I'm sure. As this little graphic shows us, well, if we didn't have proper version control, life might be similar to this, where you write a bit of code and then, well, okay, you want to add to that code, but you want to keep the original code just in case you make some changes with the next one. And so you end up saving another file and another one, and you rename it, so name the new version of the file in such a way that it makes sense. And before you know, it kind of gets out of control. We'd be manually creating all these versions of our file and trying to give them new names. And of course, it just gets really cumbersome. And this is where the idea of source control comes in. So, well, what is that? Well, it's a method that allows us to keep track of our files and keep track of the changes made in those files and keep track of them forever, hopefully. And it also allows us to share these files and share the change history of these files with other people we're developing with. And it also allows them to make changes to the code as well. So what we're specifically going to be talking about with regards to source control is a bit of software called Git. And Aaron's going to tell us a bit about that.
So why is it called Git? Well, the name Git was actually given by the creator Linus when he wrote the very first version, and he described Git as the stupid content tracker, and just went with the name Git, and it has stuck ever since. So Git is a distributed source control management system, SCM for short, and it's one of the most widely used tools in managing source code nowadays. If you're working for a tech company, if anyone's working with code with more than one person on it, in all likelihood they'll be using Git to manage it. So how do you get to use Git? Well, first things first, we're going to have to install Git on your local machine. So if you're using Windows, you're going to have to go to this link, gitforwindows.org, and there's going to be loads of good stuff there. If you're using Linux or Mac OS, you can see the two commands in the first code block. If you just run those in a terminal, it should do everything automatically. If, however, you prefer to download and install and just run through everything like that, you can go to the link in the second code block. That's git-scm.com/download. And once you've run those commands or downloaded it through the installer, you're going to need to configure it on your machine. So you run git config -- global user.name, and then within this space where it says your name, you're going to add in your GitHub username without the symbols on the outside. You do not include those. And then you'll do the same thing for your email. One thing to note, if you are on Windows, make sure you use the Git bash terminal, and this should come automatically bundled when you install Git. So what are the key Git components? So you've got the working directory, the staging area, and the local repository. So all three of these, they're part of your dev environment on your local machine. So you've installed different softwares to make it all work, and that'll be everything on your machine. And you typically work from left to right. So your working directory, this is where what you're actually changing actively in the codes to see what works. Am I writing it the right way? And once you think, yep, this is pretty much working, it will move from working directory into the staging area. And this is where all the changes are bundled up, and they'll become a commit or a transaction. And that commit is what moves it from the staging area in the local repository. And once it's there, then you want to create a mirror of that in the server, the remote repo. So you'd push that up to there, and then if something were to happen to your machine, it would be up there in the repo. Or if somebody else needed to work on the code, it's in the remote server, they can have access to it. So you also have tracked and untracked files, and I think Simon's going to talk through this for us.
Yeah. So Git tracks files that you've made changes to previously. But then also when you're writing code, you'll create new files. And until these are added to the staging area, well, they're referred to as untracked files. So basically tracked what Git knows about, untracked what it doesn't yet know about. And as I mentioned the word add there, and you can see from this diagram that to move something from the working directory to the staging area, we use the add command to go from staging to the local repository. Then we're going to use the commit command, and to go up to our server, our remote repository, then we use push. So let's just look at what those might look like in the terminal there. So git add with a file name that you want to add to your staging area. Then you might commit all of these using the commit-m and a string to say what's happened. And finally, just a simple git push command. So let's look at each of those commands in a little bit more detail. So Aaron's going to tell us about git add.
So Git add is where you mark the files in your working directory so Git can start keeping track of them. So if you've just made a new file, let's call it 404.html, just a classic this is was not found page, and Git won't know it exists until you tell it to. And there's two ways of typically doing this. You do git add and then you do 404.html, and that would just add that one file into becoming tracked. If you do a git add dot, that's a full stop. It will add everything that you've currently made or created that isn't being tracked, and it will begin tracking it. And then once it's been tracked, it can be committed. So this is all the files you've tracked. So this includes files that you've changed or deleted. So it will track these updates and bundle them into a commit. And it's very important. Well, there's two ways to do it. You can do a git commit, and when you put this command in, it'll then bring up a text editor, which you can put the commit message in. Or the much more common convention is to do git commit -m for message, and then in quote you put the message in here, and this message should just explain what the code you've edited or changed has done, what it's doing. So update function definition. If you and -m is the preferred way of doing it. And once you've committed, you'll then be able to, it will now be in your local repository and ready to go up into the remote server. So if you just do a git push, it will take all your local changes and upload them to wherever it is your remote repo is stored. And that example workflow looks like this. You're with a git add, and then a git commit, and then a git push. So once it's up there, you're going to think about sharing the code. So how do we do that, Simon? What is sharing code?
Well, what we've looked at so far works well if it's just one person writing the code themselves and wanting to keep it safe by storing it in a remote repository. But having that code in a remote repository has additional benefits, and that is it allows you to collaborate with other people within your organization. People could be all over the world because that remote repository could be somewhere in the cloud on the internet. So sharing Git repositories is really common, and Git is distributed, which means that the changes that happen in people's individual repos rather than just in a central location. Although we're storing it there, the changes that happen to begin with are done on your machine. And so everyone's repo has all of the information from the main repo plus any additional changes that they've been working on. So that means that there's no one and only source of repo information. There are various versions of it out there depending on how many people are working on it. But one way that we can bring that code together is by using an online repository, a code hosting website. And we're going to talk about GitHub because it's the most common one. It's one that we use. There are other ones out there, but this is the one we're going to look at today. It's free. It offers loads of tools. It can host your code. It allows you to search and find other people's codes on there. It can manage bug reports. You can create project task boards, project wikis. It allows you to manage what we'll talk about later. That you heard the word merge, manage, right? Merge mentioned right at the beginning. Well, merge requests is something else that can be managed through there. And it allows us to have our code reviewed by other people on the project. So yeah, it's a really useful tool. Now, another command that we'll be looking at is git status, and Aaron's going to tell us a little bit about that.
So git status is basically you're asking Git what's gone on, where am I at, I've forgotten what's going on. So it will tell you what files aren't being tracked, what files are being tracked, what changes are made, whether you've got uncommitted changes for now, or if you're working on a branch or your repo has been updated on the remote server and you've not updated yours to mirror that. Git status will alert you to all this, and if your local repo isn't up to date, you can just fix this with a git pull, provided you've not made any changes on it, and it will pull down all the current changes. And then we've got git history. So every commit in your git history is given a unique ID, and this is known as a hash. It's just a assortment of letters and numbers, and it's a way to differentiate between everyone. And we refer to the individual commits with their hashes. So as you can see in the diagram, each of these commits, illustrated by a red circle, has got a string attached to it of numbers and letters. And at the end of it, you've got head, and head is the last commit, so the end of it, it's the head. So if we were to look at your git log to look back at the history, you can see what commits have been made, when they were made, and if the commit messages have been sensible, you'll be able to decipher what's gone on. So now we're going to talk about branching. Simon, can you talk us through this?
I will do, yes. So as you saw in the previous diagram, there were lots of commits. There are a string of commits. That's our Git history. But when you've got a number of people working on a project, sometimes they want to work independently without disrupting that main flow of the code. And this is where branches come in. So what is a branch? Well, it's an alternative development path in your repository. And so branches are created on top of a commit in another branch. So we might have a main branch, and then, well, we want to break away from that to maybe experiment with the code, to try something new, to add a new feature. So we work from the most recent commit and we create a new branch. And they allow us um, to develop our code without disrupting the flow of the other people who are working on it. So this diagram could show you here, we've had a few commits in our code there, A, B, C, D. Well, now someone wants to try and create a cool new feature. So rather than affecting the main branch, because they don't know if that feature is going to turn out exactly as they thought, well, they create a new branch, they make a couple more commits, and then that comes back into the main branch and that new feature is added. So we've got some useful commands here to show you that can create branches, and I'm going to let Aaron tell you about those.
So you've got the git branch command, and then you'd add the name of the new branch you're trying to add within those brackets there. So if I did git branch add new web page, that would create the branch, and then for me to start changing stuff on that branch, I'd have to check it out. So I'd use git checkout new web page, and then I would be working on it. A much more concise or succinct way to do it is to do it all in one command: git checkout -b for new branch, and then you just name the branch, and that will do what the above two commands do, but in one fell swoop, and you don't have to type everything out twice.
Yeah.
And once you've created this and you've added stuff into staging, and from staging into the local, and you want to push it up, you'll need to make sure you've set an upstream branch in the remote, and it's you should make it match your local branch. So if I've called it new web page, I would do git push -- set upstream origin new web page, and -- set -- upstream can be shortened to just -u to simplify things. You don't have to do this if you're working on main, but it is very good practice to not work on main or develop or whatever your core branch is. You should always work on a secondary branch and then merge it in. So if you want to update the dev environment, you can do a git fetch, and that just looks at the remote repository and downloads all the commits, files, references into your local repo. And this is basically what you do when you want to see what everyone else has been working to, and you want to get your local environment up to date. Cool. So git pull, this pulls a fetch automatically. So the first fetch will be from the remote repository, and then once that's in your local repository, that will be pulled into your working directory. And it will update it to make sure it matches that, and you can just start work straight away. Once the work in a branch is done, we'll push it back into the branch we split off, and this is called merging. And the command for this is git merge, and then you are using the name of the branch you want to pull into yours. So if I'm working on a new web page and somebody else has worked on the master has worked on something else and they've put it into the master or the main branch, I need to pull that into my own. So I would do git merge main, and that would pull main, all those changes into my branch new web page, and then I'd be able to push that up. So Simon's now going to talk about different merge types.
Okay, yes. So one type that is very common is a fast forward. So this is where someone has created a new branch and they've worked on their code and they want to bring it back into the main branch, but there haven't been any changes on the main branch. So the head pointer just gets moved to where the end of the new branch is. Because there are no changes on that main branch, well, then effectively the end of the new branch just becomes the head of the entire Git history. So you can see here an example of that, where we've got there the purple dots where some code has been added, there have been a couple of commits, and then a new branch called throttle has been created, and then some logic has been added for the spaceship booster. They fixed a correction and they've done some tests, and then, well, they want to bring it back into the main branch. And so as you can see, the purple main branch just jumps to the end of the new branch, and this becomes the head and where you'll be working from. Now, with merges, if there are no changes in the current branch, there are changes in the new branch that you're creating, but the branch you're merging into hasn't had any changes in that particular area, then Git can just bring that new code into the main branch because it doesn't affect anything else. But if it does, then we call it a merge conflict. And this can be a bit of a problem. It's a common occurrence. You've been working on a bit of code. Another developer's been working on a bit of code that kind of overlaps with yours. And so this is something that Git can't handle itself, and it requires human interaction to figure this out. And that's where a pull request comes in, something that's also known as a merge request. And Aaron's going to tell us a little bit about these.
So pull requests allow us to control what's going into our main branch. So if I've done the changes, I've tested it, I think it's worked well, that's only been one set of eyes on the codes, and we're only human, mistakes are made. So by creating this own different branch and working on that, I can create this pull request to say, I want to put these changes into there, and this request then gets sent out to the rest of the team, and someone else who's one of the developers will look through my code, and if I'm doing it on GitHub, it will show them exactly what I've changed. It might be some back and forth of, oh, you've done it this way, how come you've done this? I might just explain it. They might see a better way to do it. It could be catching typos, but by creating this pull request, it gives it a chance for all these errors to be caught before anything like this goes into production or gets deployed onto a server or anything like that.
So we've talked a lot about Git. Well, we're now going to show you how to use it. First thing we're going to do, I'm going to do, is create a new repository. So I'm here on GitHub, and very simply, I just click New. And all we have to do is give our repository a name that's unique to our account. It can be the same as an account, the same as a repository on somebody else's account, but it needs to be different to the repositories that we've already created. So I'm going to call this my wonderful repo. Okay, it gives me a green tick telling me that's okay. Description, this is where I am going to write, not spelled like that, I'm not, write some wonderful code. Now I could have a choice, I could make this private if I didn't want anyone to see it. I wanted to keep it to myself, or I wanted to restrict who could see it, but I'm going to make this public. It's not that important. And we also have the option when we create a new repository to automatically add a README, add a git ignore, which is a useful file for when we want to keep things out of our repository, things that we don't want to accidentally make public, things that might include sensitive data or things that are just not necessary to other people on the project. So a git ignore could be quite useful. But we're not going to add any of those now. We're just going to create a basic repository. And that's it. We're done. We've got a repository, and this is the address of that repository. So I think if Aaron now goes over to GitHub, he should be able to find my new repository that I've just created.
I can see your wonderful repo, Simon.
Excellent. So what you can do then is follow the commands that are on here. You can create a new folder and then add this. You could git clone if you wanted to. So you want to try that,
Aaron? Yep. So I've got that all cloned on my local machine. Do you want to put a file in there to start with, just so we're both working on something?
Okay. All right. So I can do this straight from the GitHub UI. Yeah. I could, well, let's put a README in there.
So I've just changed my directory into Simon's wonderful repo, and as you can see on my screen now, if it's sharing, I've got a few plugins installed which tells me the branch I'm on is main, and I'm using Git.
Okay. So I'm putting in a commit message here for my new file. And now our repo just contains a very useless README file, but Aaron will be able to then get that file.
Yep, so I'm just waiting for my VS Code to reload. So I'm going to get a terminal up. And once that loads in, I will do a git pull. And that should bring down the files that are currently in there. So git pull. So as you can see here, enumerating 3 objects, counting objects. So it's just pulled down 3 things from the file. So if I look in my file explorer, a wonderful repo with the simple line, a wonderful code repo.
Okay. Now I could do a similar thing on my machine. Well, maybe I want to store it somewhere locally. So I'm going to create a new directory. I'm going to call it, I'm going to give it a name. So the command make dir, make directory, wonderful repo. So, and then I can cd, change directory into that, wonderful repo. And then I can also do similar to what Aaron did. I could do a git clone and then get from GitHub just by copying the URL there. And it will clone that wonderful repo. And I could also open that up in VS Code. I've got a command set up, code dot. I'll open up that folder in VS Code. Okay. Okay, so there we go. You can see we've now got my wonderful repo that has got our useless README file in there. So how about we add something to this repo? I mean, now Aaron's got access to it. He could add a new file.
Yep. So I'm going to go into my file explorer in VS Code, new file, and going to call it hello-world.txt. Very original, and I'm going to call it, add in the text, hello world, exclamation point, and I'm going to save this, and now I'm going to do a git status. Sorry, that's me misspelling it. Git status. So it's telling me I have one untracked file called hello-world.txt. So I'm going to track that, doing git add dot, which adds all the untracked files, and in this case it's just this one here. And if I run git status again, it now tells me this file is tracked. So I can go ahead and add a commit message, git commit -m for message, and I'm going to say added new text file. Hit enter, that's been added fine, and I will push it up to the remote server so Simon can also do it. Git repo, sorry, git push. Got some permission denied.
Ooh.
This might be an issue with the repo. We're just going to pause the recording for one moment. We'll be back with you shortly.
Well, as it turns out, I haven't given Aaron access to this repo, which is a good security feature that's not allowed by default. So I have to go to settings and then manage access. And from there, if you scroll down a little bit, you can invite a collaborator. So I'll type in his name. Oh, look, and it pops up there. Okay. So
Cool. I'll go check my emails
pending
now.
invite.
Okay, that invite's received. View invitation, and I am accepting that invitation to collaborate. So now, if I do a git push, It is successful. I have put my changes up onto main. So if Simon goes back into his VS Code and does a git status, hopefully it should tell him he's
It
behind.
should do, shouldn't it? Yeah. So I can see it on GitHub, but let's check from the terminal. Okay. All right. So I can now see Aaron's text, but
Nice.
maybe I don't like Hello World. I could change it for something else, couldn't I? So goodbye world. I can save this and then see if I can push it. Oh, everything up to date. What did I forget to do? Well, I haven't added anything to my staging area yet, have I? Silly me. Okay, so git add. Remember, doc just adds everything that's new. Okay, well, let's just check with a git status. Yeah, so we've modified hello world.txt. So now we need to commit it, don't we? So change hello for goodbye. Oh, spell it correctly. Okay, right, so now I'm committed and I can push it up. Okay, all right. So I've made a change, but Aaron might not be happy about that because I've just overwritten his work, haven't I? So now if Aaron pulls down what I've done.
Oh, sorry, just having some technical issues. So I don't agree with Simon's change. So I've just changed it in my file, and I'm just going to do going to save this. Going to do a git add dot. And because we're working on main, I will be able to just do a git commit minus m changed to wonderful world. And because we're not doing branches or checking if pull requests or merging works, I can just do a git push, and this will overwrite all of Simon's changes. So I didn't do a git pull, I didn't check what Simon was doing. So if Simon now does a git pull on his end, he should see all his changes disappear because I've not been very considerate.
Okay, so it's telling me I'm already up to date. That can't be right.
Ah, no, it failed to push for me.
Did it? Why is that?
Failed to push some references. So it was rejected. So the GitHub has been set up correctly. So if I do a git status, let's see what it tells me. Nothing to commit, clean tree, but I am ahead of origin master by one commit. So git push doesn't work. So maybe I can try pulling down the current changes. Oh, I've got some merge conflicts.
Right.
So what a wonderful world. That's what I've changed it to, but Simon's chain wants to say goodbye world, so I can choose to accept current change, which is mine. Hello wonderful world. I can also, if I make this window a tiny bit bigger, I can accept both changes, which would be mine and Simon, so we can say hello and goodbye. Or I could just accept Simon. So I'm just going to accept both changes now. And because I've got Simon's in here, I'm going to have to save again, do another git add. So if I do a git status, modified hello world.txt. So if I now do a git commit, and I call it merged Simon's changes with my own. Now when I do a git push, we should see it work. So that's gone perfectly. So the reason it failed the first time is because I hadn't pushed. I was working concurrently on the same code as Simon was, and GitHub didn't know if I knew about Simon's change, if I meant to overwrite them, and it stopped me doing it unless I made the conscious decision to override it or keep both. And that is merge conflicts.
Yes. So if I now do a git pull, my file has now got what a wonderful world, goodbye world together. Okay, well, sometimes that can be good, but if we only want one of them, there was no point at which we had a discussion about that. So this is where branches come in to being useful, is that you can work on a bit of code separately and then have a discussion and review it later and decide what's going to get brought into the main code. So okay, well, I'm going to create a branch.
Should I make a branch then, since this is your
Okay.
repo? I'll try and make some more
You
changes.
go for it.
So I'm doing git checkout -b for a new branch, and I'm going to call it Aaron's dash changes. So I have now switched to a new branch, Aaron's changes. So I'm just going to get rid of goodbye world. What a wonderful world. I think that is more than enough. So I am going to, in the terminal, say that again. Check what my git status is. So I've modified hello world, so I will do a git add dot git commit -m, and this message is removed goodbye. Put that in, and now if I do a git push, that goes up to my branch, but because I've not told my local repository what branch in the remote repo it connects to, it doesn't know where to push it to. So more often than not, it will just give you this command here, which if I copy and paste it, it does what it says. It will set my branch Aaron changes locally and tell it that the upstream branch is Aaron changes on the remote repo.
I mean, that is a good
So if I
feature
do a git push now,
Git, isn't it? That sometimes when you try to do something and get it wrong, it will give you the command that you need to do what you meant to. Yeah.
that's it, exactly.
All right.
So if Simon does a git pull now without changing branches or doing anything like that, nothing will have changed.
That's true. Because I'm still on the main branch. So if I look, it still says for me, what a wonderful world and goodbye world.
Well, we can still do a pull request on GitHub. This doesn't block us, so I'm going to create a pull request for the changes I made. So creating that pull request now to merge my changes into main. So I'm going to request that you review it. So if you want to head over to GitHub and have a look.
Okay, so I can have a look down here. I can see the message from Aaron, removed goodbye. I can have a look at the files that have changed. Oh yeah, I see he's gotten rid of my goodbye world. All right, well, I actually agree that's a better choice. So what I can do is leave a comment here. Good job, Aaron. That is much more positive than my outlook. Okay, and I can approve the changes. Submit my review. And well, there we go. The change is approved, and I can then merge the pull request. It says there are no conflicts here with this branch. Confirm merge. Okay, great.
Brilliant.
And then if we want to, we're all happy that branch is done with. I mean, I would ask Aaron first, which I didn't. I just clicked delete. Right. So there.
So I've just checked out main, and Goodbye World is back.
What's happened?
So that's because I haven't done a git pull yet. So because I've not done a git pull or git fetch, my local repository has the main branch unupdated because I didn't merge it on my local machine. It's only been done on the remote repo. So if I do a git pull now, it will check what the remote main branch is and pull it into here. And as you saw there, Goodbye World just went goodbye, and we are all up to
And
date.
of course, I can do the same. There we go. What a wonderful world.
Happy days. That's brilliant. Well, thank you everyone for watching, and hope to see you next time.
Bye-bye.